Okay, so we'll do another LP model, another common LP model. This one is called the transportation, also called the from to. So they will give you a table like this, and they will tell you something in the question that will identify which of these cities is your from, and which of these cities are your to. Where are you going from? Are you going from here to here or from here to here? They tell you in the question you have factories, and you have depot or final location is here. So your factory is here, that makes them where you produce, so that's where it's coming from. And supply is always associated with from. You go into 3 different cities, so you have 1, 2, 3 froms, 1, 2, and 3 twos. You're going to ship computer components, and they tell you in the table that each computer component shipped from Amherst to Miami will cost $12. Helsinki to Boston, $14. Victoria to Rochester, $20. So they give you all the costs. There are 9 different variables involved here. The way we name them, we call this 1, 1, because that would be the computer components going from 1 to 1. This would be 1, 2. This would be 1, 3. This is 2, 1 going from 2 to 1. This is 2, 2. This is 2, 3. This is 3, 1 going from 3 to 1. This is 3, 2. This is 3, 3. But instead of defining 9 variables, we do it in one step. We call the from I, we call this j. So in the actual exam paper, if you just say from equals I, 1, 2, 3, 2 equals j, 1, 2, 3, you'll be good. And you define the variables this way. Let xij be number of computer components shipped from city I to city J. And that would be good enough. The question, if you read it, is from the SAM practice exam, is to minimize cost. Minimum cost, it's $12 cost for every 1, 1. It's $14 cost for every 1, 2. $22 cost for 1, 3. It's $12 cost for 2, 1. It's $10 cost for 2, 2. It's $14 cost for 2, 3. It's $26 cost for 3, 1. It's $20 cost for 3, 2. And finally, it's $12 cost for 3, 3. Now you get into the subject 2 for this model. Subject 2, you look at your demand, you look at your supply. So I'll start with demand. Demand for first city, then Helsinki, and then Victoria. These cities that would be your supply, sorry. So we'll start with supply, it doesn't matter. So we'll start with supply, and we have the 3 cities for supply. Amherst, they can supply 3,000 units. So you ask yourself, what do we have coming from Amherst? X11 coming, X12 coming, X13. And you see I'm only taking the components, not the dollar value, because these are the components coming from Amherst, and maximum number of components 3,000. So not to exceed 3,000. That's what they're capable of providing. Helsinki can provide 2, 1 number of exponents, 2, 2, and 2, 3, not to go over their limit 5,000. Victoria, 3, 1, 3, 2, 3, 3, not to go over 7,000. We looked at demand. So we have demand for Miami, we have demand for Rochester, and we have it for Boston. Start Miami. Going to Miami, we have the X11, the 21, and the 31. They need 6,000, so you must satisfy what they need. We go and look at the next one, Rochester. We have 1, 2, we have 2, 2, we have 3, 2, and that must be at least 4,000. We have 1, 3, we have 2, 3, we have 3, 3 going for this one. They need at least 5,000. And again, as we said, all variables must be greater than or equal to 0.